Public transportation is an important service in university campus because it helps students travel between lecture hall, residential college, and other facilities. However, students often face a difficult due to the lack of information regarding bus arrival time and passenger capacity. To solve this problem, we propose an IoT-based smart bus monitoring system that provides real-time bus tracking, passenger counting, and arrival time predictions. This system aims to improve the overall transportation experience for students. The main issue faced by students is the uncertainty of bus arrival time. Students often spend a long time waiting at bus stop without knowing where the bus is or when it will arrive. Another problem is overcrowding. Students cannot determine whether the bus has arrival space before it arrives. As a result, they may waste time waiting for a bus is already full. This issue leads to poor time management, discomfort, and dissatisfactions among students. Therefore, a real-time monitoring system is needed to provide accurate information about bus location and passenger capacity.
To achieve our project objective, first we develop a real-time tracking system using ESP32 microcontroller and GPS module. Second, to design a passenger count system using infrared or proximity sensor to monitor our bus occupancy. Third, to develop a cloud-connected application that displays bus capacity and estimated time arrival.
The system consists of three main parts: data acquisitions, communication and processing, and user application. The ESP32 acts as the main controller of the system. A GPS module is used to track the location of the bus, while passenger counting sensor monitor the number of students entering and leaving the bus. The collected data is transmitted to a cloud serving using Wi-Fi or GSM communication. The cloud platform processes the data and calculates the estimated arrival time of the bus.
This is the video explanation of the software for this project. First, we have the Arduino IDE. The coding from here is to program the processor, which is ESP32. All the coding here will be saved and will be uploaded to the ESP32 to read the data and send to the database. This is the database. We use Firebase from Google. The data is the GPS and the passenger count. From the GPS, we will have latitude and longitude. The passenger count will be updated every time the sensor is hit. This data will then be sent to server. This server will connect the database and the telegram. When the GPS latitude and longitude is matched, the telegram will send notification through a bot, which is UTHM bus tracker is the bot. Let me show you an example. The latitude is set to the coordinate that match with the checkpoint, and when it is sent, you can see here notification is sent to the Telegram group. The capacity is the value of the passenger from the database, which is collected from the component itself. That is how the software works.
Step analysis. For social, this system helps a student by providing real-time bus location and passenger capacity information. It reduces waiting time, overcrowding, and improves punctuality. For technological, the project uses IoT technologies such as ESP32 GPS module and passenger counting sensor. Firebase, ThinkSpeak, and Telegram are used for real-time monitoring and notification. For economy, the system uses low-cost components like ESP32 and sensors. It helps reduce transport inefficiency and save students' time. For environmental, the system encourages students to use campus buses instead of personal vehicles. This helps reduce traffic congestion, fuel wastage, and carbon emission. For political, this project supports smart city and digital transformation in activities. It also helps improve transport planning through data-driven decision. NABC analysis. For need, students need real-time bus schedule and passenger information to reduce waiting time and overcrowding. For approach, the system uses ESP32, GPS tracking, and passenger counting sensor. The data is sent to a cloud server and updates are provided through Telegram. For benefit, the project improves user experience by providing accurate ETA and passenger information. It helps reduce waiting time and improve transport efficiency. For competition, current system only use manual schedules or simple GTS tracking. Advanced systems are expensive and not suitable for university condition. For conclusion, this project uses IoT technology with ESP32 and GPS module for real-time bus tracking. Students can receive bus arrival and passenger capacity updates through Telegram, helping to reduce waiting time and improve travel planning.